It's time for a massive upgrade to my home security cameras. I'm going from these ancient battery-powered wireless Arlo cameras to a full-blown 4K PoE wired camera system using Reolink cameras, and I'm taking you with me through the entire process. Hey there, Homelabbers and self-hosters, Rich here. In this video, I'm going to take you along with me as I install, configure, and deploy brand new PoE security cameras around my house to replace the old wireless Arlo cameras that I've been using for years, and I'll have John along with me to help with the installation. This is not a sponsored video, but for full disclosure, Reolink did send us all of the cameras, junction boxes, and the DVR we'll be using in this video. So let's talk about what we're covering in this video. Our first stop will be to talk about the location of the cameras and the Ethernet runs, and then we'll talk about the cameras we'll be using in each of those locations and why, and then we'll run the Ethernet to each of those locations where we're putting a camera, show you the camera installation, and then we'll talk about network segmentation and isolating the cameras from the rest of the network and the internet. And lastly, we'll get the Reolink DVR online, configured and storing video, and show you the final result. A successful installation starts with a good plan, so let's start there, shall we? This is the floor plan of the first level of my home. I currently have an Arlo camera to watch over the front door here, an Arlo camera here to watch over the driveway and the sidewalk, one here to watch over the side of the house, and finally here in the backyard to watch over the back door and most of the backyard. I plan to keep these locations and place the Reolink cameras in the same spots because these locations are ideal for giving me visibility over the entryways into my home and practically give me complete visibility around the perimeter of the house. Now, let's talk about the wire paths the Ethernet will take to get to these locations. My PoE switch is in the server rack located here. So all of my runs will originate from this location and terminate at each camera. Thankfully, with the exception of the run to the back of the house, all of the camera locations can be reached directly from the garage. The backyard run is complicated because there really isn't a great path to get from the garage at the front of the house all the way to the back. That's where this comes in. This is outdoor rated Cat6 Ethernet cable. What makes it outdoor rated is that its exterior jacket is UV resistant and designed to be outside in the sun or directly buried. Since it's important to me that we do this the right way, I wanted to make sure I used a cable that could withstand a lifetime outside and not break down. Anywhere a cable goes outside my home, we'll be using this cable. The run to the backyard will come out of the same wall penetration we make for the side of the house camera and run along the base of the rafters out of sight all the way to the backyard. The choice of a black colored cable was intentional to help blend into the darker colored paint of my house. So now that we have the actual plan, let's talk about the cameras and the DVR we'll be installing. Let's talk about cameras first. For the backyard and the side of the house locations, we'll be using a Reolink RLC 833A. These are 4K 8 megapixel cameras with a 3x optical zoom and have infrared and full color night vision, a built-in spotlight, two-way audio, and both person and vehicle detection capabilities. For the front of the house, we'll be installing an RLC 81PA, which is also a 4K 8 megapixel camera with both infrared and color night vision, has a spotlight, two-way audio, person, vehicle, and pet detection, and has the added feature of being able to pan left and right, which is perfect for the front of the house since the driveway and sidewalk are the largest areas to cover. Also, as an interesting feature to note, the RLC 81PA will automatically follow detected objects around as they move through the visible range of the camera, which is pretty cool. The front door location will be covered by an RLC 1224A. The RLC 1224A is a 12 megapixel camera capable of a massive 4512 by 2512 resolution at 20 FPS, and its clarity will really help catch the faces of people coming up to the front door. The camera also has both infrared and color night vision and person detection like the other cameras as well. Lastly, we can't have cameras without a place to store the video. So the final piece of gear is the Reolink RLN 440. This NVR or network video recorder supports up to 12 cameras, each with a maximum resolution of 12 megapixel and has a pre-installed 2TB hard disk for 24/7 recording. Okay, hardware show and tell out of the way, let's get the Ethernet cabling run. What are you doing?
Well, this goes in the hole, and then the hole attaches to the box.
Up there.
Yes, that's pretty much it.
This is good?
Yep.
Cool. Good work.
Oh, thank you. And there it is.
Alright, now that everything is properly cabled, tested, and working, it's time to talk about proper network segmentation of the cameras and the NVR. IoT devices need to be segmented from the rest of your network to secure and protect your other systems adequately, regardless of whether we're talking about PoE cameras, smart assistants, smart home IoT devices, etc. These systems can present a serious risk to your privacy. Let's take a look at my network diagram. This is a quick network diagram I put together to show you my existing network before the segmentation of the cameras happened. Starting with the existing setup, I have 4 VLANs in play on my home network. The first LAN on top is the Homeland VLAN. This is where all of my PCs, phones, tablets, TVs, and laptops live. If you follow the green line out of the box, you can see that the VLAN connects into pfSense and that the traffic flow is bidirectional. Next is the ServerNet VLAN in blue. It contains all of my various server VMs and container servers. It connects into pfSense as well and is also bidirectional. Next is the DMZ VLAN, which is a special VLAN for systems that host services to the outside world, like web services and a container server. If you look closely at the colored lines connecting to it, you'll notice that the DMZ network can send data bidirectionally to pfSense and get out to the internet, but it cannot reach into the Homeland or ServerNet VLANs, but they can reach into it. And lastly, we have the IoT VLAN. This VLAN contains all my various IoT devices like Amazon Echoes and smart home stuff. It also can reach the internet, and the Homeland and ServerNets can also reach into it, but devices in that network cannot reach out to any other VLAN. Now let's see what things will look like when we introduce the cameras and the NVR. The new addition to the diagram is the CameraNet VLAN with the 4 cameras within it. You'll notice there are no lines coming out of that VLAN because this is a layer 2 only VLAN and has no access to any other VLANs in the network. This means that the cameras in there are effectively segmented from everything on the network. The NVR icon shown there spans both the new CameraNet VLAN and the IoT VLAN, and that's because the NVR has multiple physical network connections on it, one for the LAN side to view the built-in website on the NVR, and a connection into the CameraNet to access the cameras and record their video. A key point to make here is that the NVR's LAN access is into the IoT network, effectively preventing it from accessing critical services or other systems that we want to protect. And because this is the IoT VLAN, we can access it from the Homeland VLAN and the ServerNet VLAN as needed. Pretty simple. We use UniFi for all of our LAN switching and Wi-Fi here, so let's configure my switches in my UniFi controller to match the network diagram we just discussed. This is the dashboard of my UniFi controller. Our first stop is to create the new Layer 2 VLAN for the cameras, so we'll head over to Settings on the left. And then to Networks. Alright, in the middle in the Virtual Network section, you can see that I have quite a few other VLANs that were not on the network diagram because those VLANs are Layer 2 VLANs for testing and are not production, so to speak, and don't have routes between them. Let's create our new CameraNet VLAN now. We'll head over and click Create New at the bottom left in the Virtual Network section. Our first stop is to enter the name we want to give this new network. As you saw in the diagram, I'm going to name this new VLAN CameraNet, and I like to add the VLAN number to the name because it makes it easy to know what the ID is at a glance in different areas of UniFi. The next stop is to enter the number I want to use for this VLAN. As you see above, I'm planning to use 400, so we'll enter 400 in the VLAN ID field. And we'll click Add. This lands us back on the Networks page again, and you can see the shiny new CameraNet VLAN is listed at the top of the Virtual Network section. Alright, we're all done here. Now we need to configure the ports on my network switch. We'll head over to UniFi Devices on the left, and then we'll click my top-of-rack switch named 2GT NW Tor. Then on the slide-out panel on the far right, we'll click Ports at the top, and then click the Ports Manager button. Okay, here is a visual representation of my top-of-rack switch. The 4 new cameras are connected to ports 19, 20, 21, and 22 currently, and we'll need an additional port to connect the CameraNet to the NVR, so we'll also be including port 18 as well. We'll go ahead and select the ports. Uncheck Ethernet port profile since we're not using port profiles here. And then in the network dropdown above, we'll scroll down and select CameraNet. The last step for these ports is to click the Apply button at the bottom, and then click Confirm to segment all these ports into the CameraNet. Now we're going to need to provision one more port for the LAN side of the NVR, and that port needs to be placed into the IoT network. So we'll head back up and select port 17, uncheck Ethernet port profile below, swing back to the network drop-down list, scroll to the IoT VLAN and select it, and click Apply at the bottom. Boom. Just like that, we've implemented our configuration changes. Now let's get the NVR set up. The first time boot of the NVR takes us through the initial setup of the system. First stop is to set up language, screen resolution, which we'll be setting to 4K for a capture card, and the date and time format. On the next screen, we set up the correct time and time zone. The NVR looks like it went out and grabbed the correct time and time zone on its own, but we did need to tell the system that we're using daylight savings time and then clicked next. Now we need to set up our admin account password for the system. The admin account is the highest level of privilege on the NVR, and this is where I ran into my first frustration. The NVR does not support a USB keyboard, only a USB mouse, which means I needed to hunt and peck through setting the password manually, which kinda sucked. Once we set the password twice, we click next. The next screen requires you to set up a password reset question and answer in case you forget your admin password and you're locked out of your NVR. Again, having to hunt and peck through the on-screen keyboard using the mouse was pretty annoying here, so I took the easy route. This screen allows you to change the host name of your NVR and allows you to format any hard disks you have attached to the system. Out of the box, the internal hard disk is all ready to go, so we'll leave things as is and click next. Here's where we'd set up the network configuration for the LAN side of the NVR. We'll be leaving this set to DHCP and DNS to auto, but if you want to set a static IP address for your network, here's where you do it. The last screen is for setting up the NVR's ability to send you an email on alert. We're not going to use email to alert, so we'll leave everything blank here and click next to finish up. Alright, now the NVR is finished with the setup, and we now see the video wall of the NVR. Currently, we don't have any cameras set up, so we'll add them now by clicking one of the Add Camera pluses. This will trigger the NVR to search for new cameras. Behind the window, we see 4 connection failed boxes appear because I had already configured the cameras when I was bringing them online, and the NVR doesn't know the admin password for each camera. Let's get them added to the NVR now. Clicking Modify on each camera will pop up the camera's login dialog box and we'll enter the password we set for each camera. Now, we'll do this 3 more times. Alright, now that we've got all of the cameras in the NVR, we can view each one individually by double-clicking on its video feed. This is the feed from my backyard camera. You can see my dogs hanging out back there. A double click will take us back out to the video wall. Let's look at the front of house camera and see if the panning works. Looks like it works just fine. Awesome. Checking the front door camera next. All looks good here. And lastly, the side of house camera looks good too. Alright, all of the cameras are set up in the system. Let's take a look at the video recording and playback functionality now. We'll pop back to the video wall and double click on the front door camera. And then at the bottom, click the playback button to look at the recorded video so far. On the left, we have the camera selection, a calendar to select the day, and in the bottom center, a timeline to scrub through. We can use the plus button on the left of the timeline to zoom in, and you can grab the timeline to move it around. At the bottom of the screen are your play, pause, and forward and reverse buttons to go through your recorded video. Pretty self-explanatory. Let's pop out of playback and look at the settings page for the NVR. All camera settings can be managed through the settings page. At the top, you can click the drop-down menu and select which camera you want to change settings on, and then modify a variety of different settings like stream settings, display settings, detection settings, and finally audio and light settings. Over on the left under channel, we have a list of all the currently connected cameras. Under surveillance settings on the left is where you configure recording, alerts, warnings, and a variety of other settings related to the recording and alerting of events from the cameras. Network shows you the current network status and allows you to make changes overall to the network configurations of the NVR. Storage allows you to see the current usage and do disk management of the NVR. By clicking the disk info button on the right of the internal hard disk, we can see smart information as well as the details of the internal disk. Looks like the 2TB drive is a Seagate disk running at 5400 RPM. And lastly, system settings, which provides you a variety of different options broken down into 5 different tabs. Under General, we can change the NVR's name, resolution, as well as other general settings. Account Center allows you to create multiple accounts on the NVR for logging into. The Maintenance tab allows you to check for software updates, including updating camera firmwares, restoring settings, and looking into system logs. Overall, the NVR does everything you'd need an NVR to do. It's not flashy and it has some quirks, but it's an affordable option that natively integrates all of the Reolink camera functionality into a single pane of glass. Also, the NVR functions best as a video wall that you'd have connected to a monitor and running in your business. The web interface of the NVR isn't nearly as streamlined. Logging into the web interface is done with the same admin user and password we set up during the initial installation. Once logged in, you're shown the first camera channel, which for us is the backyard. You can select other cameras on the right of the screen, but you'll notice that the quality isn't nearly as great as the feed from the NVR directly. You have access to most of the same settings we saw previously in the NVR setup. However, their presentation isn't nearly as nice in comparison. Oh, and then there's this. The website does not support streaming the highest resolution via HTML5, and Reolink's answer for this is to run a Flash plugin to do that. Adobe Flash ended support at the end of 2020 and is no longer available even to download on the net. That's a pretty big security risk they need to resolve. Otherwise, the web interface also allows you to view playback, download video clips, and mostly has feature parity between itself and the native NVR experience. One last thing to note, Reolink also has a web app available for Android and iOS. The user experience on the mobile app is much better than the web interface, and I highly recommend you use that app when you can. The app has the same general feature parity of the NVR with the benefit of being able to view the video in its highest resolution. Alright, so let's talk about final thoughts here. First off, the cameras. Not having any experience with Reolink up until this point, I was genuinely impressed with their build quality, their image quality, and their usability. I'm kind of surprised at what you get for the money considering competitor equivalents from Axis and others are like 3 to 5 times the price for the same features and resolution. The NVR feels kind of cheap and less polished in comparison to the cameras, but if I'm being honest, it does the job it's meant to do, and the ease of integration with the cameras makes it kind of a no-brainer. The lack of full resolution streaming on the web interface without Adobe Flash isn't cool, and something that gets the security hairs on the back of my neck to stand up. If you're looking for security cameras for your home or business, and you're considering Reolink cameras, I recommend buying the junction boxes as well for holding the cables that come out of the back of the cameras. It'll make your installations look much nicer. Finally, with all IoT devices like these cameras, make sure you take proper steps to secure your network and implement proper segmentation for them or really any other IoT device you might have from the rest of your network. And that, friends, will do it for this video. If you liked it, throw us a sub and a like, and if you have a beef with anything that I've said here, let me know in the comments below. Special thank you to our YouTube members. You guys help keep the lights on, and we thank you for it. If you'd like to help support the channel, consider becoming a member or buy some of our swag. It all helps us keep making videos. And now that you finished watching this video, how about checking out this playlist over here of other tech DIY projects we've done in the past? If you're looking for your next great project, we can help you find it.